All right. So yes, welcome to the GPUG May edition 2021. We're going to be doing static analysis with PHPStan presented by Brian Morton. So thanks, Brian, for coming out. So our agenda, I'm going to be doing a welcome, then some introductions, a word about our sponsors, on with the show, and then we're going to be raffling off some prizes at the end of this. We're going to be raffling off a 1 year's subscription to any JetBrains IDE that you might like. And that's compliments of JetBrains. So you could get PHPStorm or RubyMine or DataGrip or PyCharm or anything really. So you'll have a chance to win that at the end of the night. So stay tuned and stick around. All right. So welcome everybody. About our speaker tonight. So we've got Brian Morton coming out. So he's been nice enough to come out. Recently, just changed careers, is now the senior lead software engineer at Chick-fil-A. Very exciting. Love Chick-fil-A. He's a security enthusiast and an open source contributor. I learned from his LinkedIn page has actually contributed to Ubuntu, which I thought was really cool. Actually, I'm like, in all honesty, I thought that was super neat. And also a Pythonista, and I think that we can let that slide for the next hour and a bit. So thank you again, Brian, for coming out. About our sponsors, so I just want to say thank you to Vehicle. Vehicle has been a longtime sponsor of the GPUG. They make a lot of this work for us. So thank you very much to Vehicle. We've recently opened up public growth sessions. So it's just an opportunity. We spend a bunch of our day just practicing amongst each other. So you can go to growth.vehicle.com and you can see just a brief schedule of what type of growth sessions we'll be offering throughout the week. And you are welcome to join us and come and work with us. We do some mob programming. It's going to be lots of fun. Also, I want to say thank you to Givelify. Givelify has been a great sponsor through this pandemic. They've been offering us the Zoom link that we're using tonight to do this recording and keep things safe for us, which is awesome. And they also provide all the recordings. It's been really great having them as a sponsor of the GPUG. So thank you again to Givelify. All right, on with the show. So Brian, I'm going to stop my share and I'm going to hand things off to you. Again, thanks again.
Great. Thank you so much for the introduction, Colin, and to the group for having me tonight, the invitation. As Colin mentioned, my name is Brian Morton, and for the record, my first love is PHP. So don't get that confused. So this is a talk that I gave recently at a combined group of the Atlanta, Austin, and Boston PHP groups that we're calling Merge PHP. So if you attended that talk, you may be a little disappointed. If you did not, then you'll be in for a treat because you've never seen any of this before. So I'm going to tell you a little bit about static analysis with PHPStan. So first, let's cover what is PHPStan. So it's a static analyzer. So this is different from running or writing a unit test. This is different from parsing the PHP code, from just checking it for syntax errors. This actually parses the code and applies rules to it without executing. So we're not running the code at all, we're really just looking at the code through the lens of a parser. It's really good at finding hidden bugs. I'll run this frequently on large code bases, and you'll be surprised at the garbage that comes out of some of these code bases. Doesn't require writing any runtime tests because it's static. So you're just configuring a few lines and installing a dependency. It's very easy to use. You can use it on the CLI. You can use it in your CI/CD integration because you can use it on the CLI. You can also configure it for use in PHPStorm. If you use that IDE, I know it supports integration natively. That can kind of help you clean things up as you go a little. As I mentioned, it kind of encourages you to focus your runtime tests on your logic instead of code coverage. So there's kind of been this mantra for a while about we need to have code coverage, and there's been plugins developed to measure code coverage and ensure you have as many lines covered with tests as possible. The problem is that unit tests are time consuming to write. They're even more time consuming to maintain. And after a while in a really big code base, this becomes kind of an albatross around your neck. So for every line that you write, you've got, a 25, 30, or 40% overhead applied that you have to apply to writing and maintaining these unit tests. PHPStand's a great tool to put in your toolbox to avoid that code coverage trap. and focus your tests really where there's logic that needs to be a test, which is where your tests will be most valuable, because PHPStand won't see that. Again, it's not executing your code. So if you use Composer, it's as simple as composer require. I recommend adding the dev PHPStand. And I like to add a script in composerjson just as an entry point. That way I don't have to remember all the flags that are necessary for my particular project or configuration. I just run composer PHPStan and off we go. I like the no progress argument. It's very useful. So again, you can reuse this entry point in your CI/CD. So hopefully in whatever deployment you're using, you do a composer install. Immediately after, you can run a composer PHPStan and check the output of that. It just will return a return code. You know, you're looking for a 0 return code. Most CI/CD will error out if you give it a non-zero return code. So right there, you've got integration. Here's an example of a really simple configuration. PHPStan uses this kind of esoteric format called Neon. So you'll see the .neon extension, which is a little bit unusual, perhaps. You've also got your parameters under here. These are the most basic configuration properties. And the level there, we'll talk a little bit more about, just specifies how deep of a check we want to do. Level starts at 0. That's the most basic level of check. You can ratchet it up all the way to 9. And the documentation covers what each subsequent level entails. Finally, you want to give it some paths to check. Here I've used an example of just source. You could give it any number of paths on your project. You might not want to give it all the paths. There might be certain paths where you really don't want the code analyzed. For example, I've seen projects that didn't want their controllers analyzed, but did want to analyze the entire library. That's where it has the most value. You might not want to analyze controllers, for example, because they don't implement PSR0 or PSR4 conventions for auto loading. So you might have some difficulty with those. All right, so let's try it out a little bit. Let's go see some bugs. I'm going to actually stop my share and I'm going to share my IDE. So we'll start here, composer JSON. This is just a basic buggy project that I've made. There's a lot of bugs in here, and it only has one dependency, which is PHPStan. It's the latest version. Here's my script that I put in, and I've already installed this. I've also opened a terminal to a Docker container. For those of you who don't know, there's a little integration in PHPStorm with Docker. Makes it pretty easy to use. So we've got the project mounted and everything installed, and we're ready to run. So same code we see here. So we can just run composer PHPStan. And it prints the command that we're running, does some analysis, and it will spit out some results. Here we go. So we found 13 errors in this code. Let's take a look at some of the kinds of things that it found in our code. So this is a common one that you will see a lot: unsafe usage of new static. Let's go take a look at that code and see what it's doing. So this is the library base container. You see it's complaining about line 7. So that's return new static. Looks innocent enough. If you follow this link, they explain what actually is the problem with that. And to explain it in a nutshell, static uses late static binding. So if you extend this class and then call this method, it will actually return new whatever class you've extended it from, which may or may not have the same constructor signature. So they talk about some ways that you can future-proof this in this blog article, such as using interfaces, declaring your class abstract, etc. Again, same error here on line 12, which is doing the same thing there. One way to solve this is to use new self. That will also correct that problem, although it's really not safe to do in the static context. So here we can access to an undefined property of thing, line 17. So we can see here we're reading the property this thing, but this thing is not declared. That might be okay because you can do that in PHP, but it's warning you about it. Is probably not defined. So that's a good thing to look for. And you can see PHPStorm's built-in linter also found this problem and has highlighted it for us. Moving down, we see something kind of interesting here under the containers. We can see that it read the php.param tag here and saw that its type was array, but then looked and saw that the type int was applied here on the actual argument hint. So it understands that these things are the same and that they don't match. So it's pointing out this problem. We also see that it's pointed out that parameter 1 on line 12, we're using thing as a countable. So you can see we attempted to count this, but it knows that that's supposed to be an integer. So it knows that that doesn't agree either. So it sees these disagreements, which are pretty interesting. And obviously this would produce an error if you tried to run it. So that's a good thing to look for. I think in PHP 7.4 and newer, you can no longer feed non-countable things into count. It will actually give you an error. Another good thing to look at right here, there is no thing exceptions. That's going to be a little bit of a problem. This is one of the most common problems that I see looking at large code bases is you'll have an exceptional condition. And because the exceptional condition has not occurred or has only occurs exceptionally, we'll find the exception class actually doesn't exist. And no one's found that out, which is a very bad condition because the exceptional thing will happen infrequently. You'll then throw a fatal error because you couldn't load the exception. Really makes runtime a bit of a mess. So this is a good thing to find and track down. Oftentimes when you see these class not found, it's really because it's been misspelled. You'll see a simple typo in the name, and it's like, oh, we understand it was actually supposed to be, things exception. So looking down here, there's another type of error. We can see that our type hint said that this should return string. The doc block agrees. However, we didn't actually return string. It understands that we're returning a this, which is an instance of my container. So it knows that this is going to actually generate an error at runtime as well if you have strict types turned on. Moving through this a little bit, we could see same thing before. We've got an undefined property here on line 11. This time we were attempting to set one, but it's not defined. Here's kind of an interesting one. If you're using typed hints in PHP 7.4, it actually understands those as well. So it can see that you'll generate an error here by trying to set a string onto this property, which is declared as an int. Also here on line 18, we can see that we've got a static call to an instance method. You're really not supposed to call them that way, although PHP will allow you to. It's pointing out that probably will break. I believe that's scheduled for deprecation in a future version. This is one of my favorite ones that it'll find. So if you've got sprintf, and I've seen these bugs frequently as well, you'll have a mismatch between your placeholders and your count of fillers. And here it's pointing that out. You've only got one placeholder. You've tried to give it 2 values. That is not going to work. You also see the opposite, which is too many placeholders, and that generally doesn't do what you intended either. Down here on line 39, we can see that we've got a variable value might not be defined. So this is kind of I kind of compacted a pattern that I've seen before that causes a really sneaky bug, and you can see that it catches it. If you ever handle a for each member as byref, and then you do not unset that explicitly, you can actually mutate that value outside of it. So this is a very, very bad bug that can occur, and some of you may have tripped over this before. It can actually tell you about this in this case, that value may not actually be defined here, even though glancing at this, you would say, well, of course it's defined, it's right there. This is a very special case that it's able to figure out. So just to play around a little bit, we can see right here we're at a level 5. I raised that just to show a lot of things going on. This is a variable we had to set to detect that condition I was referencing here. It says pollute scope with always iterable for each. When it defaults to true, when we set it to false, you're not polluting the scope with that for each value. And so it understands that even though it's defined, it's not really defined outside of the for each. And you really ideally shouldn't use your for each values outside of the for each scope for reasons like this. So here we're on level 0. And we're going to run this again just to see what's going on. All right, so now we found 7 errors. So you can see there that as we reduce the error level, increase the error level, it detects more or fewer things. So let's talk a little bit about some more advanced stuff. Okay, so some tips and tricks about what we just saw. Again, start with level 0, work up, get stricter as you go, especially if you're starting with a large code base. The code base I was most recently working with at Shootproof, I think we determined it was around 300,000 lines of code. So this will handle very large code bases, but obviously, as you start higher, you're going to be creating a lot more work for yourself to get to that. There is a feature in here called baselining you can use. Let's say that you had a large legacy library, wanted to kind of freeze everything and just say we're going to improve code over time. You can do that. Scan directory is helpful if you have third-party code in your repository. You need to resolve your symbols, but you don't want to analyze it. So let's say that you've got a project where you weren't using Composer at the time. It was commonplace for a while to actually just take whatever version of the external dependency you were using, check it right into your repository. Not great, but a lot of people did it. Sometimes you need to give it scan directories to tell it, hey, that's where the stuff is, but I really don't want you to analyze it, because if there are problems in there, I don't really care. I'm not going to fix them. It's third party. Exclude paths is good just to skip analysis if you've got a particular area that's just generating a lot of errors and you don't really care about it or don't want to analyze it. You can include an area and then say exclude paths. Universal object crate classes is really interesting. This avoids false positive undefined on classes where you set properties at runtime. So simple XML standard class are automatically included, but those show you examples where the properties will not be known when analyzed statically, and you really don't want to be told about it because it's going to be whatever comes dynamically at runtime. This also applies if you've maybe built your own ORM or database result object. Again, same situation there. It will depend on whatever comes back from the database at runtime, so you don't want to be told every property is undefined. And you can list any class, abstract, interface, or a hierarchy member in there. All of those will apply equally well. We talked a little bit about this setting, which is pollute scope with always iterable for each. That's true by default, so it will not detect that error situation I showed you. Set it to false to avoid some unpredictable behavior with by-ref array values outside of loops. Really, it's good practice not to refer to those variables outside of the loop anyway, because it will always be set to the last member of your array or iterable. May not be what you intend. There's also this additional project you can install via Composer. If you want, a lot more defensiveness, this will enable all of the strict modes, and when you go there, they tell you exactly what they enable for you. But it will really tell you if something's wrong in your projects. Focus your unit tests on your areas with logic. This is just like a tip or trick. Don't worry about code coverage, because you can see if you're applying return type hints correctly, PHPStan will do most of the work for you to make sure that you're actually returning that type of thing. We don't need to mock it and execute it just to see that we can return a type from it. So here's some brand new stuff. Exception control is something just recently added. There's a link here to the blog article on the site. I think this was published maybe on May 12th, something like that, so pretty new. This is backward incompatible behavior, so it's opt-in via configuration. Two things that it can do: it can flag your checked exceptions not in the doc block throws. And first, we should back up and talk about checked versus unchecked exceptions. If you've come from a Java background, you probably have some familiarity with that. But the idea is that checked exceptions are exceptions that you might kind of expect in your code, right? So for example, you might throw a product out of stock exception. That's a checked exception. You want to make sure that your code catches that, handles it, presents the right error to the user. An unchecked exception would be maybe a database or a PDO exception. That's something that can occur. You really don't expect it to, but you probably don't want to handle those in most cases yourself. You probably want to let them bubble up and let your application handle it, present the user with the error page, log it, alert staff, whatever. So this feature attempts to differentiate these classes of exceptions via configuration. And if you have one being thrown that is not documented, it will flag it. And if you've got extra exceptions in your doc block throws, which are not actually thrown, it will also flag it, just to help you keep your doc blocks tidy. The idea is you want to be generating good documentation for any consumers of your code, so they can understand what to expect, what they need to be able to catch via checked exceptions. And that you're keeping it tidy. You're not documenting things that they don't need to worry about because that creates extra work, while also not worrying about those unchecked exceptions like PDO. We don't want to worry about that stuff. So
Ryan,
here oh, go ahead.
I just had a question actually. I don't use the PHP doc blocks too much, and I was curious in regard to the checking for exceptions and the doc block at throws exception and whatnot that you're talking about. If my method calls another method that could throw, do I have to say that the method that calls it can throw that exception if I don't catch it?
PHPStan can detect that situation if you configure it correctly. So different groups have different practices in this area. Mine has always been to document the unchecked exceptions that can be thrown from your method, including the nested things. And PHPStorm will warn you about that. So for example, trying to see if we have a good example here. So we have, I know we're throwing a product out of stock exception here. So here we can see a database exception that we're throwing. And here's our product out of stock exception. Now we need something to call check for in stock, which is the thrower. So here we'll do public function, we'll say self check for in stock. So it's static, it's not static. So here we'll have to do this check for in stock. Okay. And you can see here, it says unhandled product out of stock exception, add it to the throws tag. So that would be my approach here, is going to be actually documented, even though it occurs under here. This does become a little bit unmaintainable, and that's what PHPStan is here to help you maintain over time, because if someone removes that product out of stock exception, you'll be documenting it a level higher now. But really, it is proper to do it from a documentation perspective so that a caller understands all the kinds of unchecked exceptions they might have to deal with, or rather checked exceptions they might have to deal with out of this method invocation.
And so, yeah, like as you're saying about like PHPStan will also warn me, like if the check for in stock, if that maybe caught the exception and maybe raised a different exception or handled it some other way or something like that, that would then PHPStan would be like, yo, this method says that it throws this exception, but it actually doesn't.
That's correct. Yeah, that's correct. In fact, let's demonstrate that. So I'm going to paste in this configuration from this little sidecar file I had, and we'll just clean it up a little bit. I see it got the indentation wrong. So we've said check missing check exceptions and throws, true. And then unchecked exception classes are my database exception. You have to list all your unchecks here that might occur. And we've told it check for this. We're going to run this. I think we're still at layout. We're at level 0. So 7 errors was our baseline at level 0. All right, we found 8 errors. The additional error is here. Method myContainerSetThing throws checked exception, thing exception, but it's missing from the PHP.doc throws tag. This was in library containers mine container on line 13. And we can see here, indeed, we are throwing an exception. This one actually doesn't exist, but it does also point out I have not documented that exception. So let's go over here where we made our change in foo, because we did document this exception. Let's do exactly what you said. We're going to catch this. It doesn't do what I want. We're going to catch this product out of stock exception. And we're going to throw. That's a bad example. So we'll do a foo exception. Even though it doesn't exist, it should still flag it. Throw new foo exception. Okay. So we've done exactly what you said. We've caught it. We've thrown it. It should identify this and say, hey, wait a minute. Oh, now there's 10 errors. So it says method foo throws check exception foo exception, but it's missing from the PHP.doc throws tag. So we can see that we're throwing this right here. I think we need to enable an additional flag. Let me go look it up, see what it is. There's an additional setting. So I mentioned that these were opt-in. There's another one that will do what you were mentioning. 2 wide throw types. That's what it is. So here we'll go to our settings, and we'll say too wide throw type true. Now, if we run this, I expect that it will tell us, in addition to all of this, that we are documenting an exception in the throws that we do not actually throw. I'm not sure it actually did.
Oh, I'm sure that's okay.
Well, it should have. That was what I was expecting here, is it would have said, you don't actually throw this. Let's try this.
It'll be fine.
Well, that's what that setting's supposed to do. Too wide throws. Maybe I messed it up. Too wide throw true. No, that looks right. Yeah, here it is, but it's not thrown. But then if I back it all the way up to a try catch, I wonder if that confuses it. Let's see. This is what I was expecting, though. That does seem to confuse it when I give it this scenario. I wonder if that's just not worked out yet. But you can see here that if you document an exception, just don't throw it at all, it will very clearly tell you, hey, that's too wide. That's not what you want.
Oh, I get what too wide means now.
Yeah, it's saying you've said that you throw it, but you don't actually throw it. Apparently that try catch is enough to make it think it does throw it. I wonder if that's an unintended case.
Uh-oh.
But that's kind of a new thing. There's also a new feature called dead catch reporting. It's going to be enabled in the next major version. The error will be reported when there's a catch block for an exception that isn't thrown in the try block, which is kind of a different scenario from what we were just talking about, but still a useful one. They said it's a little too bleeding edge, but will be coming in the next version. So I'll stop my share and go back to the presentation here. Okay, and that's all the demo I have. So questions?
That was great. Thank you very much.
Yeah, I see someone here suggested that we try it with /exception. That's an interesting idea. Why don't we try that?
Yeah, perhaps I was getting confused by the class not actually existing.
That's a possibility, definitely. Here, we'll just put this all back the way it was. We'll throw exception. Looks right. Throws checked exception, but it's missing from the throws tag. But it still didn't know, but it still didn't identify this. I wonder if it can only catch one of these type of exception errors within a given scope, something along those lines. Anyway, good suggestion though. I thought it would do it.
Who's behind PHPStan? Who are
the author's name is Andrew. Let's get back to exit my full screen, get back to the first slide, second slide. Here we go. Andrew Mertes, I believe is how you pronounce his name. This is different Andrew from the one who maintains the PHP packages in Ubuntu. Similar name, but confusing, both PHPs. Yeah, he's the guy behind it, did most of the code writing, has done an excellent job.
That's a remarkable project to have on you. I wonder how many contributors he's got.
Quite a few, but very few lines contributed per contributor. I think he's done by and far the lion's share of the work.
That's wild.
Got a bunch of
contributors. The real
PHPStans. Typos and added spaces and things.
Yeah.
All very important.
Definitely some bug fixes contributed, but he does most of the work.
I did have a question.
Go ahead.
Oh, sorry. I wanted to ask. I mean, this is obviously a tool that's best used like in concert with like unit tests and sort of, I guess, what you might call conventional testing. I guess we had a great example mere moments ago. But my question is like, how much faith you put in PHPStand's analysis, given that it's not running the code, right? It's sort of, it's reading it and making its assumptions about what will happen and what won't. And they seem to be they seem to be fair assumptions, but to what level would you trust PHPStand versus a unit test versus like, it seems to be like it would be a balancing act.
It is indeed. You're absolutely right. Do I trust it as much as a unit test? No, definitely not. However, I didn't have to write a unit test. I configured a few things, installed a package, and off we went. And some of the things it pointed out may not be bugs, right? Like a missing property. But a lot of what it pointed out was definitely bugs. And you can go through and actually add annotations in your code if it's getting you false positives and things. You can turn that off. So I would give it a lot of faith. A unit test is always best, but I've spent a lot of time writing unit tests that just mocked a dependency, instantiated it with arguments, checked that I passed in the arguments, and then checked that I returned the thing. It really becomes nothing but a parser at that point, right?
Yeah. Yeah.
I mean, we're just checking passing arguments and stuff. It's pretty useless.
It reminds me of a story of a bunch of tests that I wrote when I was younger in my career that mocked a lot. It was very, very heavy in the mocks, and they actually pulled me into the room and like, listen, man, you can't do this. This is like basically you're just testing that you wrote the code the way you wrote it. And that was that was an eye-opening experience for me.
Yeah, and those do have value in the sense that you're testing the return type. Yeah, I mean, you're testing something, but it's just not very high value.
Yeah. We do have some questions from the chat. One of them was, does PHPStand work okay in GitHub Actions?
Yeah, the answer is almost certainly yes. While I have not explicitly used it myself in GitHub Actions, every CI/CD I have ever seen that when you execute a command returns a non-zero code, it will fail.
Sorry to interrupt, but yeah, I just tested because I just implemented PHPStan with GitHub Actions, and it works perfectly.
Yeah, very good.
We have another question. Have you tried other static analysis tools for PHP projects, or was this just the top contender?
I'm going to answer that along with Dave Redfern's comment here, which is Psalm is another very popular one. I have never used Psalm before. Psalm does do a lot more. It has the ability to add some security type of checks. I think it's a larger project with more contributors. PHPStand is a bit lighter and leaner, but I admittedly have not used Psalm in a serious context.
We've got Laristan here.
I have used Laristan before. I have used that before on a Laravel project, and it worked nicely. What it basically did was added everything to the universal object crates classes, so it didn't complain about the eloquent syntax.
Yeah, that's an interesting one. Like with something like with Laravel that relies so much on magic, it's interesting that you would be able to get static analysis from it that would be helpful.
It was pretty good, actually. So with that enabled, it kind of cleaned up the noise, and yeah, I was able to see some silly mistakes I had made.
So I just posted on the test with Laravel. Nuno Maduro created Laristan, which basically implements PHPStan in a workable way with Laravel, and it works really well. It's basically everything ready to go.
Yeah.
Go through the making stuff, configuring things.
Yeah, I started down the path of adding a bunch of things to excludes and then realized, oh wait, someone has already done this. And it did work very well.
Yeah.
There was something that you said earlier regarding unit tests. I think Christian touched on it there for a moment. And at first I was like, uh-oh, where's this guy going? But it was a really insightful, actually, sort of thing. I mean, like I'm not
You're gonna go with this.
say again. Oh yeah, sorry. Yes. Sorry. No, I thought it was really insightful. I mean, like I haven't actually always been like driving towards 100% code coverage, but the idea of like you're saying that there's definitely parts of your code that have higher value and have where the bugs lie, that like if you're putting in a lot of every line of code that you add, whether or not it's test or application, carries some sort of carrying cost with it, right? So if you can augment your testing with this static analysis tool, that it would allow you to focus on higher value places where you're running tests, and then like maybe make your tests run faster because there's less of them, all those sorts of things. It was something I hadn't anticipated hearing, and I thought it was really insightful.
Yeah, I agree with that, and that's kind of the mantra of PHPStand. So Sebastian Bergman, famous for writing PHP unit, has written a tool that shows lines of code, PHPLock. Here it is. So this is kind of an interesting thing to run over your code base, just because it shows you not only how many lines of code, but what was the cyclomatic complexity of these lines of code. And you can run this over subsets of your code, and there are plugins that will do this for you. So this is one good way you can figure out how complex is the code that I'm looking at. Because if it's not very complex, we probably don't need to test it, right? The things we want to test generally have logic in there. They have loops, they have conditionals, they have gates that we need to switch on or off during a given test and assert that it does behave the correct way with inputs and outputs. That's another good sign, I think, of code that's worthy of a unit test. Is, does it have inputs that change its execution path? If it doesn't, you may or may not really need this in there, right? I mean, it's very little value, again, asserting that arguments were passed in the correct order to a class instantiation or something. PHPStan will handle all of that for you, assuming that, or any static analysis will handle that for you, assuming that you've taken the time to implement, type hints for your arguments and your returns, and your libraries have too. Hopefully, you're updating your dependencies, and your libraries are doing this as well. And PHPStan will point out when things are not done correctly there.
I hadn't heard of PHPLock before. This is a tool that I'm going to start using for sure. This is really cool.
And there are some plugins for that can run also in your CI/CD to spit that out. A lot of people have shied away from the idea of full code coverage, but I do still hear it a lot from new engineers. So it tells me they're still kind of teaching this or espousing it in some orgs. I don't think that it's really a scalable thing in the long run. And I mean, that's speaking from the PHP code base at Shootproof, where I just came from, again, was over 300,000 lines of code, had been around for 10 plus years. So they know what it's like to maintain a big code base over time, and it's a lot of work. I see a question here from Daniel about PHPStan and PHPCS Fixer. Oh, sorry, Colin. Did you have another question?
No, I was going to read Daniel's question.
Oh, sorry about that.
That's fine.
To answer Daniel's question, yeah, so PHPStan, it parses the code and applies rules. PHPCS Fixer is just looking at the style of the code, mainly. There is some overlap there in that they are both rules-based. But for example, I think PHPCS and PHPCS Fixer are typically configured to look at things like where is your brace on a new line or not? What was the style of your comments? How many new lines were there between blocks of code? Things of that nature. Am I missing anything there? Is that typically what you guys see?
I think so. I always get PHPCS Fixer and PHP Code Sniffer mixed up.
I think those two tools are very similar. I think they're overlapping quite a bit.
They do overlap, and I think one just does a little bit more than the other one.
Oh, okay.
I just read about that, but I can't remember what the difference was off my head right now. Because I just implemented all of them, in GitHub Actions and everything. So all integrated with the project. So, but sorry, I can't recall right now the exact differences.
Yeah, I think they're extremely similar, however, and I think they're generally focused around the syntax of the code.
Yeah.
Whereas PHPStan is entirely unconcerned with the syntax of your code beyond errors. Does PHPStan fix code? There is a mode for PHPStan. They offer like a pro version. There is an interactive fixer in that mode. Of course, pro is their paid add-on. It enables a few things. One of them is a watch mode, so you can continuously analyze. Another is a little web UI for browsing through the errors, and another is an interactive fixer. I've never used any of those things.
That's really neat. It's great that they're trying to make money with it. You work so hard on something, you want to get some return.
Truly.
All right. Do we have any other questions for Brian? Or should we let him off the hook here? Is that, yes, that's why I would. Oh, yes. Okay. Well, Brian, I want to thank you again for doing your presentation and talking to us about PHPStan. It was great. We should give Brian a Hand of applause as well. Thanks, Brian.
Thanks, Brian.
Thanks, Brian.
Oh, thank you very much. I appreciate everyone hearing me tonight and for the invitation to come speak. Always good experience.
Thanks everybody for coming out tonight. Feel free to stick around and chat for a bit if you like. Otherwise, I'll see everybody next month.
Thanks, Colin.
Thank you, everyone.
All right. Thank you.
Bye.